You know, from a spinning planet all the way down to a salad spinner, our world is just full of things going in circles. But have you ever really stopped to think about the weird, kind of counterintuitive physics that makes it all work? Well, today, we're going to pull back the curtain and unravel the science that governs literally everything that spins.
Let's just start with a feeling we all know. You're on a merry-go-round, or maybe you're just taking a sharp turn in your car. You feel that powerful, undeniable push to the outside, right? But what if I told you that push isn't actually what you think it is? That feeling, right there, is our way into the fascinating world of uniform circular motion. So let's just dive right in by tackling that sensation head-on. Section 1, a feeling of force. We're going to explore that outward push and figure out what is really going on.
I mean, that feeling of being flung outwards, it's something every single one of us has experienced. It feels like a totally real force. And it turns out, by understanding where that feeling comes from, we can pretty much deconstruct the entire science behind circular motion. It's the perfect mystery to get us started. Okay, so before we can explain the why behind that feeling, we need the right tools to describe the what. And that brings us to Section 2, measuring the motion. Let's take a look at how physicists actually measure and talk about spin.
So the first tool is called the period, and we usually write it as a capital T. It's super simple. It's just the time it takes to make one full rotation. Just think of the second hand on a clock. How long does it take to go all the way around? 60 seconds. So its period is 60 seconds. That's it.
Now, the flip side of period is something called frequency, written with a lowercase f. This measures how many rotations happen in just 1 second, and we measure it in hertz. So if the drum in a washing machine is spinning 10 times every single second, its frequency is 10 hertz. A high-frequency object is just one that's spinning really, really fast.
And here's the key takeaway. Period and frequency are perfect inverses of each other. One measures the time it takes for a single turn, and the other measures how many turns you can get in a certain amount of time. If you know one, you can always find the other with that simple formula, T equals 1 over F. They're basically two sides of the same spinning coin.
All right, so we have our measurements, and that brings us to our next section, the constant speed paradox. This is where things start to get really weird, with a little physics puzzle that is right at the heart of all circular motion.
Okay, this is the big one. It's a bit of a mind bender. Imagine a car on a perfectly circular racetrack, and it's holding a perfect 60 miles per hour. The speedometer needle doesn't move an inch, so its speed is constant. But physics tells us that car is constantly accelerating. How on earth can both of those things be true?
The answer, and this is a huge aha moment in physics, is all about understanding that speed and velocity are not the same thing. Not at all. Speed is just a number, right? It's just how fast you're going. But velocity is your speed plus your direction. And this is what makes it all click. When you are moving in a circle, your direction is always changing. I mean, one moment you're going north, a split second later you're going a little bit west, then south, and on and on. So even if your speed never changes, because your direction is constantly changing, your velocity is also constantly changing. So what's the definition of acceleration? Well, it's any change in velocity. Doesn't matter if it's a change in speed or a change in direction. So an object moving in a perfect circle with its direction always changing is in a state of constant acceleration. Boom, paradox solved.
Okay, so that leads us to the next big question. If we have acceleration, Newton's second law tells us there must be a force causing it. And that brings us to Section 4, the center-seeking force. So what is this force?
That force has a very specific name, centripetal force. The name literally means center-seeking. It's the net force that's constantly pulling the object inward, towards the center of the circle. It's what forces it to curve instead of going straight, which is what its inertia wants it to do. This is the force that's responsible for that acceleration we were just talking about. Now, what's really important to get here is that centripetal force isn't some new magical force of nature. Think of it more like a job description. It's a role that's played by other forces we already know about. For a ball and a string, tension is doing the job. For the moon orbiting the Earth, gravity is providing that force. For your car making a turn, it's the friction between your tires and the road. So let's go all the way back to our merry-go-round. That outward push you feel, that's not a real force pushing you out. It's actually the effect of your own inertia.
Your body wants to keep going in a straight line, but the ride is constantly pulling you inward with a centripetal force. That outward push is just your body resisting that inward pull. The only real force in play is the one pointing right to the center.
Okay, so we have all the pieces of the puzzle now. Period, frequency, acceleration, centripetal force, and inertia. So for our final section, let's put them all together to solve a brilliant little piece of everyday engineering. Section 5, solving the spin cycle.
You know, the way this works is just genius in its simplicity. First, the drum starts to spin at a really high frequency. The drum's solid wall then applies a powerful centripetal force to your clothes, basically pinning them to the inside. But, and here's the clever part, that force doesn't apply to the water. So thanks to its own inertia, the water just keeps on traveling in a straight line, which means it flies right out through all those little holes in the drum.
So the next time you see something spin, you'll know the secret. There's an invisible, center-seeking force always at work. And it really makes you wonder, doesn't it? From the massive scale of planets held in orbit by gravity, all the way down to the tiny scale of electrons zipping around an atom, what else in our universe is being held in that same delicate circular dance? Thanks for joining us for this explainer.